Hello students and welcome to Smart Kids Tutorials. Many had requested for a video like this wherein they wanted a complete revision in one go. So finally I've come out with a video wherein in one shot we'll go through a super revision of the complete maths portion that will be coming for your SSC examination. This video is for both maths level 1 as well as maths 2 level 2. So both can watch. So if you are an SSC Goa board student and want to pass or score more than 40 marks, want to score high marks or even full marks, this video is your ultimate weapon. In the next one shot, I'm going to revise the entire maths syllabus, formulas, tricks, important questions, everything. So there won't be any time wasting. It will be only exam focused content and how to score maximum marks. That will be our strategy. So sit tight because this is your super revision. So we begin first with the first chapter. Okay, so you got to listen carefully. See, most students make one big mistake. They study everything but revise nothing. So it is very important to practice and revision. That is the key to success for maths. Okay, so here's your plan. You got to watch the videos, and I hope you have watched the previous videos as well that I put up. You got to note the formulas wherever you feel that okay, you need to pause and see what has been done or what you have done. Pause over there, go back, solve, and come back to this video. Okay, if you follow this, I'm pretty sure you will be able to score very well. Okay, so now let's begin with the first chapter, that is real numbers. So in real numbers, you got to understand real numbers have got natural numbers, whole numbers, integers, fractions, rational numbers, as well as irrational numbers. Okay, so because remember in the ninth standard we had done this wherein we had real numbers and imaginary numbers. So under real numbers all this comes. So what I'm saying, why is it important? So in MCQ questions you could probably be getting questions on all of this. Okay, so natural numbers are numbers that you can count on your hand, so starting from 1 onwards. Whole numbers are those numbers which start from 0 onwards, so 0, 1, 2, 3, 4, 5. And integers will include negative numbers as well. Fractions, you know, should have numerator as well as denominator. And rational numbers are those which are in the form p upon q, but q is should not be equal to 0. And irrational numbers, you know what are irrational, like the root signs and so forth. Okay, now this is what I speak about irrational and irrational number and rational numbers. Now coming to the main part. So the type of questions that you should be expecting for the examination that are usually seen is this type, wherein you have a product of LCM into HCF that gives is equal to the product of the two given numbers. So if two numbers are given and we are given the LCM and HCF of that, we can say the LCM and into HCF of those two numbers will be equal to the product of the two given numbers. Here is an example that come across. Okay, I'm not saying that this is the exact example that will come for the examination, but yeah, more likely I've solved this. The video of this you will find in the playlist, the maths. Okay, so here it says find the greatest number that will divide 306, 657, 9. So whenever it says greatest number, we are talking about highest common factor, that is HCF. So we need to find the HCF. We need to find the prime factors of each one of them. Remember, they have to be prime factors. That means we need to only find factors of prime numbers. Okay, so I have not used any 4, 6, anything of that. So I just 2, 3, 17 here, 3, 3, 73, 3, 3, 11. These are all prime factors. And once the prime factors are, once you factorize the three numbers, what they have been listed down, and then you find what is common, but it should be common between all three of them, all of them. Then that is the HCF. So you have your, you see, 3 is common and another 3 is common. So there's 3 into 3, 9 HCF. Here you have another example that could come. The HCF of two numbers is 12 and the LCM is 180. So two numbers are given, 12 and 1, the HCF is given of two numbers. is 12 and their LCM is given. So HCF and LCM is given, the two numbers are not given. So HCF two numbers is 12 and the LCM is 180. If one of the number is 36, so one number is given 36 and we need to find the other number. So we apply this formula, LCM into HCF is equal to the product of the two numbers. So HCF into LCM, so 12 into 180 equal to the product of the two numbers. Now we have been given only one number 36, we need to find the other number. We can take it as x, and that's how we get the other number. Okay, so this is what we have in real numbers. We can also have other problems under this, so revise and go through all the other problems that are there, but the focus is mainly on this. Okay, so this is about what is there in real numbers. Then we come to polynomials. Okay, now the key in polynomials is you should know about the zeros and the coefficients, and the in case of quadratic polynomials, mainly it will be quadratic polynomials. Okay, so the different types of polynomials is based on the number of terms and the number and the degree of the polynomial. Now based on the number of terms, we have monomial, binomial, trinomial. So these examples that you see are all of a single term: 2x, 6x square, 9xy. Binomial having two terms: 4x square plus x, 5x plus 4. So these are known as two terms. And trinomial having three terms: so 1, 2, 3, x square plus 3x plus 4. And based on the degree, that means the power. Okay, the power of the polynomial. So we look at the highest power of that particular polynomial, okay, or in that polynomial. Here you go, 2x plus 1. So the highest power is 1 over here, because we look at the power of the variable. The variable is x. The power, since we don't see anything on top, that means it should be 1. Okay, so the highest power of this particular polynomial is 1, and we call this as a linear polynomial. Then we go to the quadratic polynomial. Here the highest power is 2, because see, the variable x is here and the power of this one is 2, power of this x is 1. There is no x over here, that means the power should be 0. So the highest power in case of this polynomial is 2, and that's why we call it as a quadratic polynomial. Then same thing applies for cubic polynomial. Highest power, if you see over here, is 3, and that is why we call this as a cubic polynomial. Now if you have a polynomial which is in the form, especially a quadratic polynomial, which is in the form ax square plus bx plus c, wherein a is the coefficient of x square, b is the coefficient of x, and c is the constant, then we say that alpha and beta are the roots of that particular polynomial. So if you want to find out the sum and the product of the zeros or the roots of the polynomial, roots are also sometimes interchangeably called zeros of the polynomial. Okay, so the sum of the roots is given by alpha plus beta equal to minus b upon a. Where is this alpha plus beta? Is sum of the roots. Where did this minus b upon a come from? Now, b is from this b, coefficient of x, and a is a coefficient of x square. And this is the formula, minus b upon a. And the product of the zeros, that is, this is the product, alpha into beta, is equal to c upon a. The c is this constant c, and a is this coefficient of x square. So this is how you get the sum of the zeros and the product of the zeros. Here is and one more thing over here. Alpha and beta are the roots of the quadratic polynomial. Then the polynomial is given by. So sometimes you will be given the zeros of the polynomial, and sometimes you will also given the sum of the zeros of the polynomial and also the product of the zeros of the polynomial, and asked to find the polynomial. So in that case, this is the formula. The formula is the given polynomial is given by, if the polynomial is in x. Okay, please note, sometimes they will tell you to find the polynomial in y or some other letter. So don't write every time in x. If it doesn't say anything, then you write it in x. If it says that it's polynomial in x, then you write it in x. But if it says polynomial in any other letter, then you write it in that letter. So if it says y, so you write it p of y, and this will become y square. Okay, and this will become y over here. So anyways, so the polynomial is given by x square minus sum of the roots into x plus product of the roots. Okay, so in other words, x square minus alpha plus beta into x plus alpha into beta. So if only alpha and beta are given separately, okay, then you add them up. That will be the sum of the roots of the polynomial. And you multiply the two zeros or the two roots that are given, that will be the product. This is how you get. And this is a division formula, okay, algorithm. Dividend is equal to divisor into quotient plus remainder. Okay, so p of x is equal to, we have done this in the 9th standard also, okay, but more likely to come is this one, okay, compared to this. So this is your dividend, this is your g of x is your divisor, q of x is your quotient, r of x is your remainder. So r stands for remainder, q for quotient. Only you need to remember g over here is your divisor and p of x is your dividend. Okay, so we'll move on. So sorry, we'll just go through this problem here. Find a quadratic polynomial, the sum and the product of whose zeros are minus 2 and 5. So here you have been given the sum directly. So this is the sum, these are not the roots, these are the sum of the zeros of the polynomial, and this is the product of the zero. So you have to find the quadratic polynomial. So here what has been done is the sum of the zeros is minus b upon a, it's put as minus 2. So what you can do is you can directly write x square minus, we'll follow this, where is this, here, x square minus, now sum is given, right? So that will be minus 2 will come over here. So minus and minus will become plus, and you'll get plus 2x, and instead of alpha into beta you will put 5. So you'll put 5. So you'll get this answer, x square plus 2x plus 5. This is done in a slightly different way. You can do it this way also, or you can do it in this fashion, wherein alpha plus beta is already given as minus 2 and alpha into beta is given as plus 5. Only just take care of the signs, because there is minus sign outside and you have been given the alpha plus beta is minus 2, so that will be minus 2 also inside. So minus and minus becomes plus, minus into minus becomes plus. Next problem, find the sum of the zeros of the quadratic polynomial. 4x square minus 12x plus 5. So we need to find the sum and the zeros of the polynomial. So direct see, so sum, so if we compare this to ax square minus bx plus c, so a is 4, b will become minus 12, and c will be 5. Okay, we are only looking at the coefficient of x square. Coefficient of x square is a, and in this case it is 4, so a is equal to 4. Coefficient of x is minus 12, so that is b, and this is constant, which is equal to 5. Our formula for sum of the zeros is what? Minus b upon a. So minus b is minus 12 upon a, which is 4. So 4 3s are 12, and minus into minus become positive 3. Okay, that's how you solve this one. Next, moving to chapter 3, that is pair of linear equations in two variables. So general form of a linear equation is ax plus by plus c equal to 0, where a is the coefficient of x, b is the coefficient of y, and a and b cannot be 0 simultaneously. Okay, so a pair of linear equation is usually represented in this form: a1x plus b1y plus c1 equal to 0, and a2x plus b2y plus c2 equal to 0. Cross multiplication method is not there for you all. You already have the elimination method, and you have got the substitution method. In graphs, in linear equation you can also have graphs. So by graphical method, if you notice, you get a unique solution. Now unique solution meaning that you have only one solution to the problem. So that means there will be one value of x, one value of y. So in this case, you notice, this is what we need to remember. When we have this pair of linear equation given in this way, a1 upon a2 should not be equal to b1 upon b2. When a1 upon a2 is not equal to b1 upon b2, we say it has got a unique solution, and the graph will look like this. Intersecting the two lines represent the two equations, so they will only meet at one particular point. That is when it is a unique solution. If there is no solution, then a1 upon a2 should be equal to b1 upon b2, should not be equal to c1 upon c2, and the graph will be like this, where the two lines never meet each other. They will be parallel to each other. Okay, so these questions are usually asked about these graphs and so forth in MCQ, multiple choice question, and we have infinitely many solutions. So here we will not have any solution, okay, for x and y. Here we will have many solutions for x and y. Remember, in this case we have only one value of x and one value of y. Here, if we change the value of x, the value of y will also change. So many solutions like that. So here you see there's only one line, because the other line is coinciding with this, the other line. So there are two lines actually over here, but they are coinciding with each other. It makes it look as if there is only one line. That's why it says line 1 and line 2. Okay, so all the points will match with each other, and that's why you have a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. Okay, so such system is said to be consistent and dependent. A system where there is no solution is said to be inconsistent, and a system where you get a unique solution or only one solution is said to be consistent. So one solution is consistent, many solution is consistent and dependent. Okay, you can say one line is dependent on the other one, or one variable is dependent on the other one, and here it is inconsistent. Okay, now here there are two solutions. One is shows you an example of pair of linear equations solved using elimination method, and the other one shows you an example of a pair of linear equations solved using substitution method. Okay, so these are the two methods that you have in solving pair of linear equation, two variables. Okay, so you have over here, you see there is two equations, 7x minus 3y, 5x minus 2y equal to 11, 7x minus 3y equal to 11, 5x minus 2y equal to 8. So we mark them as 1 and 2, and then what is done over here is we are looking to eliminate this y variable. So to eliminate y variable, we have multiplied them with opposite numbers, so that taking the LCM, we take the LCM, we just need to multiply this equation 1 with 2, so that this becomes 6y, and we multiply the second equation with 3, so that this becomes 6y. Okay, first thing is that the variable, in order to zero out the variable or cancel the variable, okay, or eliminate the variable as we say, the numbers or the coefficient of the variable should be same, and they should have opposite signs. So we'll look into opposite signs later on. First thing is to make the variable coefficient of those variables same. So when we multiply this by 2, this becomes 22, this becomes 6y, this will become 14, 2 into 7. And when you multiply the second equation by 3, 3 into 8 is 24, 3 into 2 is 6y, 3 into 5x is 15x. Now that the variable number and the variables are the same, but the signs need to be opposite, so we change the sign throughout. What is plus becomes minus, what is minus becomes plus, and this is plus, this becomes minus. So now that the opposite sign, this gets cancelled. 14 minus 15 becomes minus x, 22 minus 24 becomes minus 2. Please note, once you change the sign, the new signs should apply. Okay, and do not do the mistake of saying 14 minus 15 is positive x. Okay, it is always the sign of the greater number, so do not forget to put minus, and do not be afraid of the negative sign, and do not eliminate the negative sign at your will. Okay, or you will lose your marks also at your own will. So minus x and minus 2, minus and minus cancel on both sides, we get x equal to positive 2. This x we can now substitute in any other equations, equation 1 or equation 2, to get the value of y. Okay, so by eliminating one variable, we got the other variable, the value of the other variable. Now that we have got the value of the other variable, we substitute it in any one equation to get the variable that was eliminated in the first place. So here in this case it is x equal to 2 is put into equation 2. So wherever there is x, you put the value of x, that is 2. So this will become 5 into 2 minus 2y equal to 8. Do not put it over here. These are your main equations, equation 1 and 2. And we get 5 into 2 is minus 10. When we take it, 5 into 2 is 10. When we take 10 on the other side, it becomes negative. Minus 2, do not get rid of this minus 2. This has to remain here. Minus 2y equal to 8 minus 10. 8 minus 10 is minus 2 and not positive 2. Minus and minus cancels off, and 2 and 2 also cancel each other. So we get y equal to 1. And so the solution is x equal to 2 and y equal to 1. Next we come to substitution method. We have two equations here as well. 7x minus 2y equal to 3. 3x minus y equal to 1. So your choice, you can take either this one or that one. Well, I would take this one because there's no variable for y. That makes it easier for me. All I need to do is take this minus y on the right hand side, that will make it positive, and I bring this 1 on the left hand side, that will make it negative. But in doing so, I will get directly a variable which is equal to some value, okay, with a variable. So we use equation 2 and we take minus y on that side, and we get y equal to 3x minus 1. So we mark this as equation 3. Now this value which we have assumed, we have got over here, y equal to 3x minus 1, we need to put it into an equation to get the value of x, okay. But the key over here is whichever equation you have got this value from, like we have got this from equation 2, right? We cannot put it back into that. We need to put it in the other equation. So we put this y equal to 3x minus 1 into equation 1 because we have not used it at all. So wherever there is y, 3x minus 1 will come this way. So 7x minus 2 into wherever the y was, 3x minus 1 equal to 3. So now we open the bracket, we get 2 into 3x, 6 minus 6x minus 2 into minus 1 will give us positive 2, and 3 we bring on the left hand side, we get minus 3. If you want, you can leave the 3 on the right hand side also, no problem. I would leave the I would leave positive 3 on the right hand side. Anyways, it has been brought this side, so we'll solve it now. 7x minus 6x, so 7 minus 6 is 1. So instead of writing 1x, we just write x over here. And minus 3 plus 2 gives us minus 1. That minus 1, when you bring on the right hand side, becomes positive 1. So that's why I said you can leave this 3 on the right hand side. Finally, you have to bring it on the right hand side. So we get x equal to 1. Now that we get x equal to 1, we can put it in equation 3 to get the value of y. Okay, so if we put that, so in place of x, we put the value which we have which we have obtained. So y equal to 3 into 1 minus 1, like this. We get 3 into 1 is 3, 3 minus 1 is 2. So we get y equal to 2. So do not forget to write, therefore the solution is x equal to 2, y equal to 1. Therefore the solution is x equal to 1, y equal to 2. Okay, it has got half mark. Chapter 4, Quadratic Equation. Okay, now in quadratic equation, we need to know the standard form of a quadratic equation. Ax square plus bx plus c. We even come across this in our quadratic when we do quadratic polynomial. So x equal to ax square plus bx plus c equal to 0, where a, b, c are real numbers and a is not equal to 0. Okay, so a is not equal to 0 over here. Now we have two methods over here. So one is the factor method and one is the quadratic formula method that we need to know under quadratic equations. And then there are word problems as well, okay, under quadratic equations. So I'm not going to go into the word problem, but just discussing about how to find the roots of a quadratic equation, either by the factorization method, or how we called it in 9th standard, splitting the middle term, and the quadratic formula methods. We discussed the formula and how to use the formula, how to use the factorization method. So in the first case, we discussed the rules to find the quadratic form. So we have this equation here, 3x square plus 7x plus 10 equal to 0. How do we find out the roots of this? We have to look at the signs, the sign of the middle term and the sign of the constant term. Okay, very important. So in this case, the middle term is positive, b is positive. If you know what is b, b is referring to the coefficient of the middle term. See, it's in this form, right? Ax square plus bx plus c. A is the coefficient of x square, b is the coefficient of x, and c is the constant term. So that is why it's saying b is positive. So that is positive, and c is also positive. Okay, so when both b and c are positive, that means the middle and the constant term is positive, then the two factors are also positive. So we need to find the factors in such a way that when we multiply the constant term with the coefficient of the first term, that is coefficient of x square, okay, the product should be 30. So in this case, 10 into 3 is 30. But when we add the two factors, we need to get two factors such that we need to get when the two factors are multiplied, it should be 30. Okay, how we got 30? 10 into 3. So constant term multiplied into the coefficient of x square, 30, and 30 now you can get in different ways. 10 3 is a 30. Now we got here 10 3 is a 30. Okay, but when we add the two factors, okay, it should give us 13. So 10 plus 3 is not 13. We need this 11. It should be 11. So you get to find different ways in how you can find 30. So that will be 30 into 1 is 30, 10 into 3 is 30, 15 into 2 is 30. But the one that we are looking at is 6 into 5 or 5 into 6. Because 6 into 5 is 30 like all others. But 6 plus 5 is 11. And that is why. So both the terms should be positive, and these are certain conditions to look at. Okay. So that is one. So in the next, we look at the middle term is negative. So b is negative, but c is positive. Okay. So if b is negative and the c is positive, that tells you that both the terms or both the factors should be negative, because when both the factors are negative, when you multiply the two factors, you get positive result. But when you add them up, it still remains negative. Okay, like for example here, multiplying 10 into 4 will give us 40. Okay, now there are different ways how 40s can be. 10 into 4, then 20 into 4, 8 into 5. Okay, all these are giving us 40, but when added up it should give us 13. Okay, so both factors should be negative. So what gives us 13? Only 8 plus 5. 8 plus 5 gives us 13, but since it is negative, that means both the terms have got to be negative. So negative 8 and negative 5, okay, will give us negative 13, but negative 8 into negative 5 will give us positive 40. Okay. Next, when the middle term is positive but the constant term is negative. Now in this case, the product is negative, but the when added up, subtracted, okay, the highest factor has a positive value. Okay, so this is the sign of the greater number, positive. So 6 into 5 will give us 30. Now what gives us 1? X, there's only x over there, that means the coefficient is 1. So what gives us 1? It should be 30, but it should be 1. So this itself will go 6. So positive 6 minus 5 will give us positive 1, but positive 6 into minus 5 will give us negative 30. So it satisfies this. Over here also, you see the sign of the constant term is negative, or C is negative, and B is also negative. So this once again is the same thing, that when the two factors are multiplied, it should give us negative, but when the two factors are added or subtracted, then it should give us negative. That means here the sign of the greater number should be negative. So you have 30 and you have 2 over here. That means 30 into 2 is 60. So various ways 60s are possible: 30 into 2, 60 into 1, 12 into 5. So 12 into 5 will be the most logical one, because negative 12 plus 5 gives us negative 7, but negative 12 into positive 5 will give us negative 60, the way we get here. See, this is minus 30 into 2 gives us minus 60. Okay, so these are certain things how we use factorization method. Now, if you feel comfortable with the quadratic formula method, you can use quadratic formula method. Only you got to be careful with various things. So, what is the formula? The formula is x equal to minus b plus or minus square root of d upon 2a. So, we have a b, we have a, which we are familiar by now. What is d? D is known as discriminant, and that also has a formula. Okay, so instead d is equal to b square minus 4ac. Always try to find the value of d. Reason is, see, if the value of d is less than 0, okay, if the value is less than 0, that means it will have no real roots. Like for example over here, so if discriminant is less than 0, that means it is negative or something. That means we can't find any roots and the problem stops over there. But the discriminant, if it is equal to 0 or greater than 0, then that means we will have real roots. Now if discriminant is equal to 0, that means we will have uh, uh, that means we will have identical roots. Okay, two real identical roots. Okay, and if we have d greater than 0, that means we will have real roots but distinct roots. Okay, so that means let's say in this case this is a case of real and distinct roots. Okay, so all of these are actually real and distinct. That means for x you have plus 6, for x you have plus 5. Okay, so distinct roots. Okay, that way we are. So in this case you try to find out the discriminant. Okay, it will be greater than 0. That's how you get it. So quadratic formula usually quadratic polynomials usually have two roots. So d is always try to find d and see if the discriminant is equal to 0, greater than 0. Okay, and once you find that, you can directly substitute that value here and use this. So a is x from here, coefficient of x square, b is coefficient of x, and c is your constant. Okay, minus b plus or minus. So plus or minus tells you that we will have two roots. Sometimes they are also identical. Okay, let's move to two solved examples of splitting the middle term or finding factors, and also the quadratic formula method. So 4x square minus 4x minus 15 equal to 0. Okay, so once again we do minus 15 into 4. So the constant term is negative, middle term is negative. That means is the in case of this one. Okay, so you will have the sign of the greater number will be negative, and there will be a negative and the positive. So minus 15 into 4 gives us negative 60, but we need it in such a way that the middle term is 4. So 10 into 60, 10 into 6, sorry, gives us 60. So minus 10 into positive 6 will give us negative 60, and negative 10 plus 6 gives us negative 4. So we put over here, you can either put the negative 10 here, or you can put the negative 10 here and 6 here, no problem. Accordingly, the what you find common will change. So here we have 4x square minus 10x plus 6 minus 15. So this minus 4x is split up into minus 10x plus 6x. Okay, just another way of writing minus 4x. Now we find what is common between 4x square and minus 10x. We see that both have x in common, so we take out x, and we also see 2 times table is common between both of them. So if we take out 2, what remains inside is 2x, and what remains inside is minus 5. Here also we look at what is common, so there's no variable common between the two, but there is, both of them go in 3 times table. So we take out 3, what remains inside is 2x and minus 5. We see 2x minus 5, 2x minus 5 in common, we take that out first, and what remains behind is 2x plus 3. So we get two factors here, and we write either 2x minus 5 equal to 0 or 2x plus 3 equal to 0. We take minus 5 on the other side, and the 2 comes down, we get x equal to 5 upon 2. Same way over here, take plus 3 on the other side, will become negative 3, and 2 we bring it down, it become x equal to minus 3 upon 2. So therefore the roots are 5 upon 2 and 3 upon 2. In case of using the quadratic formula method, we have 2x square minus 5x minus 3 equal to 0. So first thing is we compare it with ax square minus bx plus c, and we get a is equal to 2, b is equal to minus 5, c is equal to minus 3. First we find the discriminant to see whether it is equal to 0 or greater than 0. Okay, so we put in place of b square minus 4ac, so b is minus 5 whole square, minus 4 into a, which is 2, and c, which is minus 3. Minus 5 whole square is 25, minus 4 into 2 is 8, 8 into 3 is 24, minus into minus is positive. 25 plus 24 gives us 49. And now we substitute in the formula to find the roots. So that is minus b plus or minus square root of d upon 2a. b is minus 5, and do not forget the minus sign outside of that b, plus or minus square root of 49 upon 2a. 2 into 2, that gives us 4. Square root of 49 is 7. Minus into minus 5 gives us positive 5. So we can say x is equal to 5 plus 7 upon 4, or x is equal to 5 minus 7 upon 4. 5 plus 7 is 12 upon 4. We cancel that, we get 3. 5 minus 7 is minus 2 upon 4. We cancel that, and we get minus half. So that's why therefore our roots, do not forget to write the last sentence is dropped out of over here. Just do not forget to write that. Therefore the roots are 3 and minus 1 upon 2. We come to chapter 5, that is arithmetic progression. Okay, it's a mathematical sequence in which the difference between two consecutive terms is always a constant, and it is abbreviated as AP, or arithmetic progression. The first term is denoted by A, and the common difference is denoted by D. Okay, so, and the number of terms of an AP is given by as n. So example of an arithmetic progression is 5, 9, 13, 7. See, if you want to know whether any sequence that is given to you is an arithmetic progression or not, you just need to compare the differences. If the differences is common between any two successive terms, okay, that means the it is an arithmetic progression. This given sequence is an arithmetic. Otherwise it is not. So like for example, you see this is the 9 minus 4, 9 minus 5, sorry, will give us 4. 13 minus 9 will give us 4. 17 minus 13 will give us 4. Okay, so successive terms are the difference between the successive terms should be the same. Then we have d equal to 4. A is the first term, so in this case it is 5, and so on. Okay, up to the nth term. So arithmetic progression can be written terms of common differences. So the first term is given, a1 is given as just a, second is given as a plus d, a plus 2d, a plus 3d. You can also find out by putting it into this formula. This is the general formula. An is equal to a plus n minus 1 equal to d. N is the number of terms. So if you put in place, n should be actually subscript down, small one. If you put n equal to 1, so then this will become 1. N equal to 1 minus 1 is 0. 0 into anything is 0. 0 into 2 is 0. So that will give you equal to a. That's what we get. And so on. If you do this, you will be able to get all the terms. Sum of the first n terms is, so all the terms, if they added up, we should get some value, and that this formula helps us to find that value. So Sn is equal to n upon 2 in brackets 2a plus n minus 1 close the bracket into d. Okay, so you should know this formula as well. This is another formula finding the some of the first and last terms when it was given. Okay, so I have not included that. If you know these two general formulas, should be more than enough. Again, this is not going through each and everything that is there in the syllabus, just touching upon the main parts of every chapter to quickly finish off this revision. So we have this example over here. Select and write the most appropriate alternative from those provided in the bracket. You'll be given the 10th term of an arithmetic progression with the first term as 2 and common difference of 5 is what? So if you want to find the 10th term, we have been given the first term and we've been given the rest. So that means A is given and D is given, and we need to find the 10th term. So we apply it in this general formula, which is here an. So in place of A10, so A will be 2, N will be 10, D will be 5. Okay, so 10 minus 1 is 9. 9 into common difference 5 gives us 45. 45 plus A, which is 2, gives us 47. So the correct answer is here, 47. Now another example, find the sum of the first 81 terms of an AP whose second and third terms are 16 and 21. So we are given the second and third term, we are not given the first term and the common difference. But from the second and third term, you can easily find the first term and the common difference. So here you go, when the second and third term is given. So the second term will be that will be a plus d equal to 16, and this will be a plus 2d equal to 21. Okay, and that will give us a is equal to 16 minus 5. Yeah, so d is 5. So you got to work this out. Don't do it this way, okay, but you can easily work it out, okay, by using elimination method. Okay, let me see if I can show you here. Okay, so you, the second term a 2 will be equal to 16 a plus d. A2 will be a plus d, and this third term will be a3 will be equal to a plus 2d. Okay, so then you can easily use that. Okay, and we have been given a2 as 16, so in place of 16 you will a2 you will have 16, and in place of a3 you will have 21. Use elimination method, you will easily be able to eliminate a and get the value of d. After you get the value of d, put it into one of these equations to get the value of a. So we get over here a as we get a as 2 and a as 1 and a as 11 and d as 5. Okay, so you substitute the value in, so S81 you need to find out, n upon 2, so 81 upon 2 and 2 into a plus n minus 1, so 81 minus 1 into d, and the answer is 17,091. Next we come to triangles. So this time you have only got to focus on similarity of triangles and basic proportionality theorem. So remember, two triangles are said to be similar if their corresponding angles are equal and their corresponding sides are proportional. Equiangular angles means all angles are equal, that the corresponding angles are equal, and the ratio of any two corresponding sides in two equal angle and triangles is always the same. Criteria for similarity, this is more important for you. Okay, in three ways in which we can actually say two triangles are similar using the AAA similarity. Even AA similarity will work. Okay, when angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle, so corresponding angles are equal. SAS similarity, which means side angle side. Okay, it can be anything. So it can be AB AB upon DE is equal to AC upon DF, and angle E is equal to angle D, something around this side. Okay, and triple S similarity deals with only with sides, all three sides. So AB upon DE should be equal to AC upon DF should be equal to BC upon EF. That is triple S similarity. And we have the basic proportionality theorem. So I'm sure everybody will be knowing this. If you don't know this, please do. For level 2, it is a guaranteed question. So if you lose 3 marks, it is your 3 marks to lose. This 3 marks you should easily be able to bag. But do not by heart this particular theorem, because now I'll give you an example over here. Okay, now over here I have a complete figure over here where everything is joined, everything is done. Okay, however, there's one thing that's not joined, that is I do not have P, that is perpendicular line coming from P perpendicular to this DF. Okay, so that is not shown, so you may get confused, or in the class when it is solved, or for your tuition class when it is solved, the figure might be complete. Okay, and the letters may also change for the examination. So understand how to solve this theorem and then go for the exam. If you try to by heart, you'll end up writing what you have learned, and the same thing may not match with what the question paper is asking you, and you will end up losing all your 3 marks. That is why I say it is your 3 marks to lose. These 3 marks are a gift, especially to level 2 students. Level 1 students don't get this at all. Level 1 students have to solve a rider. Level 2 students is a gift, and if you can't take that gift, then that's your problem. Okay, over here we have been given in triangle DEF, PQ is parallel to EF, where points P and Q lie on DE and DF respectively, and QM is perpendicular to TE. We need to show or prove that DP upon PE is equal to DQ upon QF. So that is what it says, no? What does the basic proportionality theorem says? It says if a line is drawn parallel to one side of a triangle, if a line like this PQ is drawn parallel to one side of the triangle, which is EF, to intersect the other sides in distinct points. This line is drawn parallel to this side of the triangle, but it is intersecting other side of the triangle at a distinct point, it is Q. Then the other two sides are divided in the same ratio. That means these two sides are divided in the same ratio. TP upon PE is equal to DQ upon QF. That is what. Now we need to prove this. The theorem says that, but we need to prove it. Okay. So what we start with, see, we need to know the first thing is that area of triangle formula is what? Area of triangle formula is half base into height. Remember, area of triangle formula is half base into height. So base, now we look at the triangle area of triangle DPQ. Okay, base is what? DP. Height is what? MQ or QM. So half base into height area, and this full triangle upon the area of this triangle, okay, that is PQE. Okay, PQE. Again we apply the half base into height. Base is PE, but height is this one. You will say this is crooked. Why this height? Why not this PQ? Because height is always perpendicular. When you take your height, when you go to a doctor's clinic or something, there's a chart measuring the height. How is it, crooked or straight? And how do you measure? You measure yourself crooked or straight? Straight, right? So it has to be 90 degrees. So that is why we take this as the common height. So QM. Now QM and QM cancel, half and half cancel, and we are left with dP upon PE. So using area of triangle, this thing, we get this. So mark this as 1. Similarly, now we go to the other side of the triangle. Same triangle we take, but we look from the other side, this side. That is DF side we look. So we have DPQ area. Here the base now will be DQ. Okay. And the height, okay, we need to construct a height which is not here over here. So we can, if this is M, we'll give that N, let's say. Okay. So we give that letter N. So to construct PN perpendicular to DF, we can say. Okay, with the N on the side DF. So PN will be a height. So half into P base will be DQ, height will be PN. It's not shown over here. I'm telling you, you can try it, doing it by yourself. And this particular triangle, like how we took this triangle, this particular triangle, that means PQF, base will be QF, height will be PN. PN and PN will cancel, half and half will cancel, and we'll get DQ upon QF. See, the whole idea is we need to get DQ upon QF in one equation, DP upon PE in one equation. That's it. Now that we have got these two, how do we show that they are equal to each other, comes the question. Okay, then if you notice, we have got DPQ same. If we can show this area of triangle PQE equal to area of triangle PQF, done, then we can easily say this is equal to this. This DPQ is the same. We just need to show area of triangle PQE is equal to area of triangle PQF. Where are these two triangles? Here. And you notice they are sharing the same base. They are sharing the same base, and there's also one more thing. They are between the same parallel lines. You remember PQ is parallel to this EF. So there is a theorem which says that if two triangles, okay, if they share the same base and they lie between the same parallel lines, then the area of the two triangles are equal, and that's what we say over here. So if this is what we wanted to show, this triangle, area of this triangle equal to the area of this triangle, and we have told that, giving that reason. So now we can easily say, so from 1 to we mark this as 3 also, 1 2 3, we can say that dP upon P is equal to dQ upon EF. That is as simple as this basic proportionality theorem. And there will be problems, MCQ type questions, 2-mark questions on this PPT. Riders are most probably expected to be on basic proportionality theorem, but you could also get a simple rider based on just similarity of triangles as well. Coordinate geometry, chapter number 7. Okay. So main thing to remember is distance formula, then the section formula, and the midpoint formula. This time you do not have the area of triangle formula. There is no parallelogram formula as such. You just need to know a property of the parallelogram, that the diagonals meet at a point, midpoint. Okay. So distance formula, straight shot, if you have one point with x1 coordinates as x1 comma y1 and b as x2 and y2, the distance between the two is given as square root of x2 minus x1 whole square plus y2 minus y1 whole square. Then I'll come to the parallelogram last. Section formula, if a corresponds to x1 comma y1 and b corresponds to x2 comma y2, is divided by a point P, x comma y in the ratio m1 is to m1, then the coordinates of the point P is given. So if you have a line, two end points have two coordinates and they are divided by a point in between in certain ratio, okay, in certain lengths. Okay, so that point which is dividing the two also has coordinates and the ratios are given as m1 and m2. We don't know whether they are equal, they are unequal, we don't know. Okay, sometimes it is given, sometimes not given, you have to find it. So the section formula is given as this one. Now how do we remember the section formula? Remember, 1 comes first, 2 comes next, and after 2 comes 1. Okay, so always the way how I remember it, I always write this thing first. See, below it's always m1 plus m2. So on top also I always write m1 plus m2 first. Okay, and if 1 comes, next should come 2. If 2 comes first, the next should come 1. There's no 3. Okay, so I write m1, leave this blank, plus m2, leave this blank, write m1 plus m2. Once I've written m1, next should come 2, but x2. Now here there is m2, next should come 1, so I put x1. And then once I write, this is the x-axis, I just need to write y-axis. So this entire thing, the only thing is x I replace with y over here. That's it. That is as simple as how you can remember the section formula. Okay, and here also in case of distance formula, it's just that x2 minus x1, y2 minus y1. Can you write x1 minus x2? Yes, you can write x1 minus x2. You can do it x1 minus x2, but if you do x1 minus x2, it should also have y1 minus y2. Okay, that is the key. There is no need that you have to do x2 minus x1 only. You can do x1 minus x2 also, and you can do y1 minus y2. So there is no compulsion in that. Just make sure if you start with 1, it should be 1 2 for both x as well as y. If you start with 2 and 1, it's 2 1 for both x and y. And then the midpoint formula. Now the midpoint formula is very simple. It's in the section formula itself. See, in the midpoint formula, okay, midpoint means both the lengths are the same. So if this length is the same, that means the ratios are going to be the same. Ratio means what? It's just a length. So m1 is equal to m2 in the midpoint. So that means if this is 1, this is also got to be 1. If m1 is 1, m2 is also 1. So if I place m1 as 1, I put, and m2 is also 1. 1 plus 1 gives you what? 2. So 2 over here. And if I've taken m1 as 1, in place of m1 I write 1. So I don't write 1 into x2. Why do I need to write 1? Just write x2 plus x1. Or as I can say m1 plus x2. That's it. And y1 plus y2. You can remember, you can write it also x2 plus x1. It won't make a difference. Whether you write 2 plus 3 or 3 plus 2, the answer is always going to be 5, right? So just remember the section formula, the midpoint formula will come automatically. You don't have to remember this midpoint formula. Just remember in midpoint formula, the ratios are the same. Just put 1 in the ratios and you'll get your midpoint formula. Now we come to the what is given about the parallelogram. So now in parallelogram, so if x1, y1, x2, y2, x3, y3, x4, y4 are the vertices of the parallelogram. Okay, these are the vertices of the parallelogram. Then the midpoint of AC is equal to midpoint of BD. Where is AC? AC is here. BD is where? Here. So their midpoint is equal. Okay, so they bisect each other. The diagonals of a parallelogram bisect each other. That is the whole idea behind this thing. And so their midpoint should match. So midpoint of AC should be equal to the midpoint of BC. And I told you about midpoint. Okay, everything is upon 2. So that's it. So you have the different lengths over here. x1 plus x3 upon 2. And you have AC. So don't worry about this thing. So x1 plus x3 upon 2 and y1 plus y3 upon 2, okay, should be equal, this whole bracket should be equal to x2 upon x4 upon 2, comma y2 plus y4 upon 2. Okay, so these are the formulas. We have some problems over here. Find a relation between x and y such that the point x comma y is equidistant from the points 3 comma 4 and 7 comma 2. Find a relationship between x and y such that point x comma y is equidistant from the points 3 comma 4 and 7 comma 2. So we say over here, let p x comma y be equidistant from a comma 3 and 7 comma. So pa should be equal to pb, correct. If you draw a line, if you draw a line, okay, so here we have got a and here we have got b, and right bang in the center here we will have p. Okay, so pa should be equal to pb, that is what is saying. So but if we take pa, okay, see the distance formula, it has got a square root, right? So what we do is square on both sides. We got square on both sides, we get rid of this square root sign. So we are left with what is there inside under the square root sign. So this is how we get it, and we just need to establish a relationship, okay, in terms of x and y. We don't have to really find their lengths or something. The next problem is find the ratio in which x-axis divides the line segment joining the points 3 comma minus 10 and minus 1 comma 5. Also find the coordinates of the point of intersection. Okay, so we are told there is a find the ratio in which the x-axis divides the line segment. Okay, so first of all we take the ratio as k is to 1. Okay, we take the ratio as k is to 1 and we use the section formula. So we take m1 plus m2, right? So m1 will be k, m2 will be 1. So that's why we have k plus 1. Wherever we have the sorry, we substitute in the section formula and get this way. So this is what we'll get. Now we are told that if the x-axis, that is dividing the line segment. So if x-axis is x-axis is dividing the line, that means y should be equal to 0. So this should be equal to 0. 5k minus 10 upon k plus 1 should be equal to 0. So that's why I said therefore it's ordinate. Ordinate means y-axis. Abscissa means x-axis. So 5k minus 10 upon k plus 1 equal to 0. K plus 1 into 0 will become 0. And so we will get 5k minus 10 equal to 0. When we take minus 10 on the other side, it becomes positive. Cancels 5 into 2. And we get k is equal to 2. So we have assumed here ratio, right? K is to 1. So k is equal to 2 is to 1. Okay. So that's how we get this thing. So also find the coordinates of the point of intersection. So we can do that further on. I've not shown it over here. You can find that out later as well. So this is just an example of how we solve such problems. Now chapter 8 we come to introduction to trigonometry. Here we need to know the different trigonometric ratios. Okay. Then we need to know the trigonometric table. Okay. And certain identities. Okay. And then only we can go to solve their problems. Okay. This table and this ratios also will be come in handy when you are solving word problems in applications of trigonometry. So very important to know. So if you don't know this chapter, you will not be able to do anything in applications of trigonometry as well. Now I won't go deeper into this because I have done in quite extensively about got 2 or 3 videos about this introduction to trigonometry, how to remember the different ratios and the tables, and identities are also given. So I won't go a lot into details into this overall. So we've got sine, we've got cos, we've got tan. If you remember sine, cos and tan, the remaining becomes easy. See Opposite of sine is cosec, opposite of cos is sec, opposite of tan is cot. When I say opposite, it just means that if you, whatever is in the denominator, if you take in the numerator and the numerator you take down, this becomes cosec. If we apply the same thing, cos becomes sec, and if we apply the same logic, tan becomes cot. Okay, so sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, and tan is opposite upon adjacent. And cosec is the opposite of this, it's just hypotenuse upon opposite. Sec is the opposite of this, adjacent, hypotenuse upon adjacent, and cot is the opposite of tan, which is adjacent side upon opposite side. Okay. Now whether the side is opposite or adjacent depends on where your angle is. Okay. The one which is right angle, this applies only to right angle triangles, by the way. Okay, not to any other triangle, just right angle. So the right angle will remain where it is. There can be two angles, one can be here, another can be at this point. So either angle A, angle C in this example. Okay, so if it is angle A, the opposite side is this one, adjacent side is next to it. Okay, but if the angle is at C, then the opposite side becomes this one and the adjacent side will become this one. Okay, so this is the trigonometric table. Learn the trigonometric table for 0, 30, 45 degrees, 60 and 90. All you need to know is learn for 0, 30, learn for sine and cos. The remaining should become very easy. Again, I said I'm not going to go through individual table, that will take a long time. I will put the link to those videos if you would like to revise and see how they have been done in the description box below. You may go through them. I'll try to put as many links as possible in the description box below, whatever videos I've done. If you like, if you have the time, you can go through them. Okay, so you have certain identities are there, like sine square theta plus cos square theta equal to 1, 1 plus tan square theta equal to sec square theta, 1 plus cot square theta is equal to cosec square theta. Here some tricks has given, like if you have 1 plus sine theta upon cos theta multiplied with the numerator but with the opposite sign, 1 minus sine theta upon 1 minus sine theta, and then you'll get 1 minus sine square theta, which is equal to cos square theta. Same over here also, I will say you have a cos upon 1 minus sine. So you take the LCM. LCM will be multiplying 1 plus sine A into cos A, 1 minus sine A into cos A, and 1 plus sine A into 1 minus sine A. That will give you cos 1 minus sine square theta A, that is cos square A. Okay, so this is all about practicing this type of problems. The more you practice, the more familiar you'll become with the type of problem. Okay, and certain other things, remember I told you over here also, opposite. So 1 upon sine theta is cosec theta, 1 upon cos theta is sec theta. Same way 1 upon tan theta is cot theta, or 1 upon cot theta is tan theta. Same thing you can say about sec theta. 1 upon sec theta is cos theta, 1 upon cosec theta is sine theta. You just need to play around with it, that's all. Okay, so here's an example that is given. Evaluate the following. Hope you can see this. 5 cos square 60 degrees plus 4 sec square 30 degrees minus 10 square 30 degrees, whole thing upon sine square 30 degrees plus cos square 30 degrees. Okay, now see, it is given sine square 30 degrees and cos square 30 degrees. Okay, now when it's given sine square 30 degrees, cos square 30, here the values are removed. Okay, what I would suggest to you is, do not remove the values. Sine square theta plus cos square theta, see the theta is the same, right? Theta means the angle, 30 degrees 30 degrees, and if it is sine square cos square, same angle, the value becomes 1. So instead of all of this, you can just write 1 over here. Just need to find out the numerator, that's all. Okay, just given to confuse you, make it more complicated, that's all. Otherwise the value should be 1. Okay, now you need to find cos 60, and you need to find sec 30, tan 30. For that you should know this table, and then carry out the addition, division, whatever that is needed. In case of this one is given triangle FED, right angle at E, and cos D is given as root 3 upon 2, root 3 upon 2, okay, cos D. So cos is what? Cos is adjacent upon hypotenuse, okay. So if you apply that over here, adjacent will become root 3. So D will become root 3 and hypotenuse will become 2, okay. And then use the Pythagoras theorem to find this side. Once you find this side, you can easily find tan f and sin f. This is tan square f plus sin square f d. Sin square d you have to find. Remember one thing over here is that look at the angle that is given to you, okay. And another thing over here, it is not solved that way, but we use the k method. So you need to take root 3k to k. So this will be d will be equal to root 3k and df will be equal to 2k, and so whatever value you get fe will also be in k because of the k method. When you get the ratios, the k gets cancelled off and you get the proper value, okay. So some applications of trigonometry, you will either get a problem which is speaking about elevation. So when you look from when someone looks at a tall building from the ground, it is angle of elevation. But if somebody who is on top of the building looks at the bottom of the building or a bottom of a tree, okay, then it is angle of depression. That's all, okay, because the line of sight of anybody is always straight. So when you look down, it's always the angle of depression, okay. And in case of that, your angle which is there is always given here, but we get the angle there because this angle is equal to this angle, because this line of sight is parallel to this side, this ground, okay. And since they are parallel, this forms as a transversal. This angle of depression forms as a transversal, and so we can say by alternate interior angle, this angle that is formed here, angle of depression, is equal to the angle that is formed. Alright. So angle of depression will become same as the angle of elevation, okay. We'll look from the ground. That's all. Okay, so here there's a problem that is solved. It's more for level 1 than level 2. Level 2 will not have such a problem, okay. And if you see over here, it's given from the top of a tower PQ. So this is a tower PQ, angle of depression of the top and bottom of a 7 meters tall building. So AB is a building, and angle of depression at the top of the building and at the bottom of the building is given. The top of the building is 45 degrees, bottom of the building is 60 degrees, 45 degrees, 60 degrees. Find the height of the tower PQ. So we need to find this height. Height of the building is given 7 meters. So this length is always equal to this length because we are talking about a rectangle. Okay, so opposite sides are equal. So 7 meters. We need to find this one, this part. Okay, and anything else we are given? Also find the distance QB. Okay, from the foot of the tower to the foot of the building. Sorry. And we have to take root 3 equal to. So remember, whenever they give you take root 2 or root 3, do not take it in between. Take it right towards the end. When finally you get root 3, take it over there. Because sometimes in between, keeping the root 3 helps in cancellation or something. Do not look to substitute. You also will end up getting a different answer compared to what the person who has set the paper has written down on the answer key. So keep the root 3 right towards the end, and at the end when you get root 3 for the final answer, write 1.73 into whatever other value number that you have in front of it. So here we have over here so first what we'll do is we'll assume PR over here as x. So this full length, this will be PQ will be x plus 7 or 7 plus x. you can take it anyways. And we take over here we take tan of 60 degrees. Okay, so tan of 60 degrees will be tan of 60 degrees will be PQ upon QB. PQ is your x plus 7 and QB is y. Over here is given, and tan of 60 degrees is root 3. So we will get root 3 y plus x plus 7. Okay, so we can so we can keep it that way itself. And here we'll have to take in this particular triangle. Now that was in PQB. In triangle PRA, we take tan of 45 degrees. That will be PR upon AR. So that will be x upon, and again AR will be equal to QB because they're rectangle. Opposite sides are equal. So x upon y. Tan 45 is 1. That means x becomes equal to y. This we can put over here. That's what is done over here. X is equal to y. Okay, so instead of y, x has been put. So root 3x minus x we have over here equal to 7. 7 has been left this side. So x is taken on the left hand side, become minus. So here instead of root 3 is substituted with 1.73. 1.73 minus x, 1.73 minus 1 it is. That gives us 0.73x. 0.73 goes down, and we multiply top and bottom, numerator as well denominator by 100. 0.73 becomes 73. 7 into 100 becomes 700. It comes to 9.59 approximately. So that is x. X is what? This. So this 9.59, if we add to 7, we get the height of the tower, which is 16.59. Okay, and then it comes to y. We said x is equal to y, so that means y, the distance between the foot of the tower and the building, is 9.59 meters. Do not forget to write the units. If you don't write the units, you will miss your half mark. Half mark will be cut. When we come to chapter 10, which is on circles, in circle there's not much. This is the main proof theorem. Apart from that, there are others as well that have been coming. We can go through them. I've not mentioned. Problems are also coming mainly on this. Okay, so you could also get a proof on this. Okay, so very easy to prove. So, but the main thing you should know that the length of the two tangents of a circle are always equal to each other. Okay, whenever it is drawn from an external point, okay, to the circle. Okay, so here also PA is equal to PB. Now, if we are asked to prove that PA is equal to PB, we need to take these two particular triangles, PAO and PBO. PO is a side common to both triangles. OA and OB are radii of the same circle, so they are equal to each other. And PAO is equal to PBO because they are right angle. Okay, why they are right angle is because tangent radius, where the point at which the radius comes in contact with a tangent, at that point a right angle is formed. Okay, so angle PAO is 90 degrees and so is angle PBO 90 degrees. So by right angle, this becomes the hypotenuse because it's the side opposite to the right angle, and one side by RHS, these two triangles become congruent to each other. And because they are congruent to each other, not similar, congruent to each other, because they are congruent to each other, we can say that PA and PB, two corresponding sides of the two congruent triangles, are equal to each other by CPCT, that means corresponding parts of congruent triangle. And here is another theorem. It says that the tangent to the circle at any point is perpendicular to the radius of the circle that passes through the point of contact. Same thing that I used over here. See, and there are other theorems also, you may go through this, but this is the main theorem, and based on this there will be problems coming. Okay, so the next one is area related to the circle, Okay, now in area related to circle, there are different formulas that you need to remember. So a circle has got a radius, a center, a diameter, a circumference, which is also same as the perimeter. So area of circle is given as pi r square. Circumference of a circle is given as 2 pi r and sometimes as pi d, because diameter is nothing but radius plus radius, which is equal to 2r. That's why it's pi d. Okay, diameter is 2 times r, or radius is half of the diameter. Area of semicircle is given by pi r square divided by 2, half of the full circle. Area of sector is given by theta upon 360 into pi r square, and area of a quadrant is given by 1 by 4 pi r square. Okay, actually you can also write it as theta upon 360 pi r square, but a quadrant is 90 degrees. See, 90 degrees. So 90 degrees upon 360 degrees, if you cancel, you get 1 upon 4. This part remains the same over here. Length of an arc is given as theta upon 360, but 2 pi into circumference. This is into area, this is into circumference for length of an arc. 2 pi, because we are looking at length and not the area inside. Here we are looking at the area inside. Here we are looking at this length, outside one, perimeter. So area of a sector is all given r upon 2, length of an arc, that way also it is given. Square, certain properties of square, formulas. Area of a square is given by side square, or a square. Perimeter is given by 4 into side, or 4a. Diagonal of a square is given as side into root 2. Okay, and then we have a rectangle which has the length and the breadth. Again, formula: area of rectangle is given as length into breadth. Perimeter of a rectangle is given as 2 times length plus breadth. Diagonal of a rectangle is given as square root of L square plus B square, length square plus breadth square. Regular hexagon, okay, is hexagon. These are ones that we don't use so frequently, but just mention it over here. May come. 3 root 3 upon 2 into side square. Perimeter of a regular hexagon, 6 into the side. Area of any triangle is given by half base into height, particular one. Equilateral triangle, area of an equilateral triangle is given as root 3 upon 4 into side square. Trapezium, area for trapezium is given by half into the two parallel sides into height. Rhombus is given half into diagonal 1 into diagonal 2. When it comes to circles, okay, so when a circle is inscribed in a square, means when a circle is inside a square, the diameter of a circle and the side of a square are equal. Okay, that is one thing to remember, should be used in the problems. This was a circle inside a square, but what if the square is inside the circle, as in this case? So when the square is inside the circle, okay, the diameter of a circle becomes equal to the diagonal of a square. Okay, we are given that the diameter of a circle is equal to diagonal of a square, which is equal to x root 2, or side root. Okay, so the diameter x side root 2. Okay, and when a hexagon is inside a circle, okay, the side of the hexagon, this side, okay, will be equal to the radius of the circle. Certain things to remember. And when a circle is inside a hexagon, okay, the radius of the circle is given by root 3 upon 2 into side. Now, this here is a problem that has been done. So, in the given figure of sector QSPR, so where is QSPR? Here is. Here you go. Triangle PQR is an isosceles triangle. That means two sides are equal. This PQ is equal to QR. Angle Q is 90 degrees, it says. PQ is 7 centimeters, so the QR also becomes 7 centimeters. Find the area of triangle PQR. So that we can easily find by using half base into height formula. Half into base into height. Okay, that comes to 49 upon 2, that is 24.5. So we get this. We need to find the area of sector QPSR. So QPSR, this full sector we need to find. So area of the sector is given by theta upon 360 pi r square. Theta is 90 degrees. Pi is 22 upon 7. Okay, so take pi equal to 20 upon 7 is given. And r is 7. Okay, so this becomes the radius. These are radii. So 90 upon 360 is 1 upon 4. Okay, that we multiply 2 2s are 4, 2 11s are 22. Okay, and 7 and 7 cancel, so we get 77 upon 2, which is 38.5 square centimeters. Note over here, area is given as square centimeters in both cases. Okay, so units of area is always with square centimeter, and with volume it is cubic centimeters or liters. Okay. Also note, if centimeters are given, you write centimeters. If meters are given, you write meters. Next, we come to surface area and volume. Again, you got to remember all the formulas. For those who do not skip out the entire surface area volume, if possible, try and at least memorize the formulas. So wherever a problem comes on surface area volume, same goes with area related to circle. Memorize the formulas if you can. Okay, write it on a piece of paper and memorize it at the last moment before getting into the examination hall. However, don't take the cheat inside. Okay, don't do that. You'll be caught and then you will be barred from that examination. So take a cheat so that you can quickly glance through it before going into the examination hall, and then keep it in your bag and go. Okay, so in this way you don't have to turn pages, but memorize them and go. So in case of a problem comes and you don't know how to solve it, but you know that okay, that it's talking something about a cylinder, volume of a cylinder, and you know the formula of volume of cylinder, just write down the volume of cylinder formula and keep. You may get a half mark for that. Something is better than nothing, right? It's better to get half a mark rather than 0. Can play an important role. So here are the formulas. For a cube, it is side cube, total surface area is 6 side square. For a cuboid, volume is length into breadth into height. Total surface area is 2 times into length into breadth into height, and you can say height into length. Just go one after another. Lateral surface area is 2 times breadth into height plus length into height. Right circular cylinder, volume pi r square h. Curved surface area is 2 pi r h. Total surface area is 2 pi r square plus 2 pi r h. Exactly, it's like that. Okay, but when you take 2 pi r common, what it remains is 2 pi r into h plus r. Volume of hollow cylinder with radius is for those who have done that, so I won't confuse it with those who have not gone through the volume of hollow cylinder. Right circular cone, volume 1 upon 3 pi r square h. Slant height is finding the using the Pythagoras theorem, so that is square root of r square plus h square. Curved surface area is pi r l, where l is the slant height. Okay, so that l is here. Total surface area is pi r into l per r. Okay, so that is the solid sphere. So volume is 4 upon 3 pi r cube. It is curved surface area is 4 pi r square, and then you have solid hemisphere. Volume is half of this. So when you have half, 2 cancels 4, and you get 2 upon 3 pi r cube. Curved surface area, same thing, half of this, so you get 2 pi r square. Total surface area is 2 pi r square plus this top pi r square, giving you 3 pi r square. Okay, we have got 2 problems over here. We look just an example. A hemispherical depression is scooped out from one face of the cubical wooden box of edge 5 centimeters, such that the diameter of the hemisphere is equal to the edge of the cube. Okay, then find the inner curved surface area of the hemispherical depression, this one, the lateral surface area of the cube. Do not substitute for the value of pi. So when it says do not substitute the value of pi, do not substitute the value of pi. Okay. Sometimes it get cancelled. Sometimes in the final answer also you get pi. But if it is said do not substitute for pi, then do not do that, or you will get the answer wrong and you will get a 0. So first thing we do is find the inner diameter. So inner diameter. So we told the edge is 5. Same thing as 5. Okay. Sorry, the not the diameter. This is wrong. It's the radius. So the diameter is the same as the edge, which is 5. So half of that will give us the radius, which is 2.5 centimeter. So in order to find the inner curved surface area of the hemispheric depression is half of 4 pi r square, or you can say 2 pi r, half of, you can say 2 pi r square directly. Okay, so 2 pi we don't substitute, r square is, r is 2.5 into 2.5, and we get 12.5 pi square centimeters. Okay, then finally we come to the lateral surface area of the cube. We need to find that. Okay, 6 into the edge. Okay, 6 side square. Side is 5 centimeters, so 5 into 5 into 6, that gives us 150 square centimeters. Okay, we get that. Now that is solves this one. We go to the next problem. A 16 meter deep well with diameter 7 meters is dug up and the earth is spread. Earth means the mud is spread evenly out to form a cuboidal platform of height 7 meters. Find the area of the base of the cuboidal platform. And here it is told take pi 22 upon 7. So the volume that you take out by digging, the volume of that mud is equal to the mud that is spread. Okay, so the volume of the cuboidal platform that is formed. So volume of the well, we are told that it has a diameter of 7 meters. It is 16 meters deep. Okay, so it is 16 meters deep. Diameter is 7. Okay, so we take the volume of the well. So we take pi r square h. So that, see, well is in the form of a cylinder, right? So the volume of cylinder given is pi r square h, and the cuboidal platform, which is the area of the base into height. So pi r square is 22 upon 7 into 7 upon 2. 7 upon 2 because 7 is the diameter. You want, you can write 3.5, or you can leave it as 7 upon 2. So sometimes it is better to keep it in the fraction form because everything gets cancelled and you don't get any decimals. Okay, so into 16. Why 16? Because height is 16 meter deep. It was 7, right? So 7 cancels with 7 over here. 2 cancels, 7 and 7 cancels. 2 11s are 22. This 2 cancels. 2 into 8. So 8 into 7 into 11. Okay, we get that is equal to the area of the base of the cuboid. Okay, and we get the area of the base of the cuboid over here. We get that remaining value. So you can work this out and see how you get this answer. Okay, so but this is an example, not necessary you will get something like this. Okay, and again it's quite different from level 2 and level 1. Okay, you must have practiced already the problems. So here we are not there, we are not looking to practice problem, just to see how problems are being solved. Okay, using the formula. Just a quick recap of the entire syllabus. Statistics. Okay, so these are the formulas for statistics. Again, here I have not focused on the graph, the ogives, less than ogive and more than ogive. You can go through them. The chances of them coming are less, but I'm not saying that they can't come. They can also come, but more likely to come is to find the mean using the assume mean method, or by the step deviation method for level 1. For level 2 it will be by assume mean method. For level most probably it will be by the step deviation method. Okay, so we have the direct method where mean is equal to summation of fi xi into sum upon summation of fi. By assume mean method it is the assume mean plus summation of fi into di whole thing upon fi. By step deviation method it is assume mean method plus summation of fi ui it is upon fi into h. And you've got the median. The median is lower limit of the median class, n upon 2 into cumulative frequency upon frequency into height, and mode also you have lower limit of the model class, f1 minus f0 upon 2 f1 minus f0 upon minus f2 into h. And this is an example of finding mean by the assume mean method, where you will be given the class intervals and the frequencies. You'll have to add up the frequencies. Sometimes given, get the class marks, and here you are not given the assume mean. Sometimes you're given the median class and asked to take those class intervals as assume mean. Here you can take any one of them and then calculate and see. So here we have taken a as 65. So di you get by xi minus 45 minus 65 gets minus 20. 45 minus 55 is 10. This is easy. If the class interval is 10, so the difference here also will be all 10. Minus 20 minus 10 0 10, and then fi into di 5 into minus 20. So you just need to do, you don't need to do 5 into minus 20, just do 5 into 2 10 with a 0 towards the end, so 100. Here 29 into 1 29 with a 0 at the end, 290. 36 into 0 is 0. 10 into 1 is 10. If you know 10 times table, fine. 10 into 10 is 100. Otherwise 10 into 1 is 10 with a 0. And then do not forget to write the negative signs wherever they add them up. You will get fi summation of fi di. A is 65, summation of fi di is minus 20, summation of fi, which is a total of fi frequency, is 80. Get this value and you'll get your mean or mean literacy. Don't forget to write the final statement saying that the mean literacy rate of the 80 cities is 61.378. That's how you solve this one. And then we come to probability. Okay, now probability is very easy for most of you. Just need to remember this formula: number of favorable outcomes upon the number of all possible outcomes. Remember, the probability of a sure event is always 1. Probability of an event that is impossible to happen is always 0. And the probability of any event always should be from 0 to 1. Okay, it cannot be less than 0, that means it cannot be negative, and it can't be more than 1. If you get a value more than 1, you are wrong. If you get a value which is negative, you are wrong. Okay, probability always ranges from 0 to 1. Remember that. Okay, common examples are that of coin, of cards, and some balloons or some balls. Okay, all these are common examples. Remember, if there are two dice are thrown simultaneously, okay, then you need to all possible, you'll get 36 possible combinations. This is how you get, okay, with 2. This 1, 1 represents the number that is on the face of one dice, and other one represents the number that is coming on the same on the other dice when the two are rolled simultaneously. So this is how you get all the possible combinations. With respect to 2 coins, okay, you will get 4 combinations: heads, 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 tail, tail, heads, tail, tail. But when the 3 coins are tossed, you will get 8 combinations. Okay, 8. So 2 is to 3, 2 raised to 3, you get 8. 2 is to 2 raised to 2, you get 4. That's how it works. Okay. 52 playing cards. Remember the 52 playing cards. 26 are red, 26 are black, 13 of diamonds, 13 of hearts, 13 of spades, 13 of clubs. Remember, there are 12 face cards. Face cards are those which have a face on them, that means king, queen and jack. Remember, joker is not part of the pack of 52 cards. There are 4 aces. Let's look at some examples. The probability of a sure event, I told you, is always 1. 2 dice, 1 blue, 1 grey, thrown simultaneously. Find the probability of getting the sum equal to 6, getting exactly 6, 1 and 6 on either, getting exactly 1, 6 on either die. Okay, so we have got 2 dice, 1 blue, 1 grey. Okay, the color actually doesn't matter. We just need to get the sum equal to 6. So if you have the sum should be equal to 6. So we will have here this one. Okay, 5 plus 1, 4 plus 2, 3 plus 3, 2 plus 4, 1 plus 5. That's it. So 1, 2, 3, 4, 5. Only 5. 5 upon total possible 36. And the other one is getting exactly 1, 6 on either die. Getting exactly 1, 6 on either die. So either this one or that one. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not this one, because we have said either. That means either this one or that one, not both. Okay, so totally 10. 10 upon 36. We divide that. 2 5s are 10. 2 into 18 is 36. 5 upon 18 is our answer. Okay, so that is how we get it. So this is about probability. Finally, we come to the last chapter, that is logarithm. We need to know the rules of the logarithm, the laws of logarithm. So product rule, log of this b is referring to the same base. Log of x into y, we can write it as log of x plus log of y. Log of x upon y written as log of x minus log of y. Log of x to the power y can be written as y times log of x. Okay, log of 0 is undefined. You just need to know this. Log of 0 is undefined, and log of 1 is 0, and log of any number to the same base is always 1. So if you are told log of 42 to the base 42, you'll say, I don't know, I've not learnt it. No, log of the number to the same base is always 1. So log of 42 to the base 42 is always 1. Same thing goes with anything. Log of 29 to the base 29. The base should be the same. Okay? Then you can say that the value is 1. Okay? So that is laws to remember. Now here are two problems that are solved over here. 2 times log of 5 plus 4 times log of 2 plus log of 75 minus 1 upon 2 log of 9. How do we solve this thing? Okay, we don't what do you say, go to find the log of 5 and so forth. See, work it out. So 2 times log of 5. Okay, we use this law, but in a reverse fashion. We say log of x raised to y, we can write as y the log of x, right? That 2 times log 5 is in this fashion. We can bring it in this fashion. That is log of 5 raised to square. Log of 5 raised to square is log of 25. Okay, go to the next one. Same thing we can do here. 4 times log of 2 can be written as log of 2 raised to 4. Log of 2 raised to 4 is log of 16. Okay, 2 raised to 4 means 2 into 2 into 2 into 2. That comes to 16. Log of 16. Here we have log of 75. We leave it the same. Here it is minus half log of 9. Same thing. Okay, that means 9 raised to half. 9 raised to half is what? Square root of 9. Okay, the value of square root is half. So 9 raised to half means square root of 9. Square root of 9 is 3. So now we have got log of 25 plus log of 16 plus log of 75 minus log of 3. Okay, so this we can convert it into this. See, this is in this form and this form. Again, we have to go reverse. Log of x into y we write it as log of x plus log of y. Now this is in this form, log of x plus y. We can convert it into log of x into y. So log of 25 plus log of 16 plus log of 75 can be written as log of 25 into 16 into 75. And this is minus log of 3. And this is in this form. Log of x upon y is equal to log of x minus y. Okay. So this minus y minus log 3 is in this form. We need to convert it upon x upon y. So this minus log y will become upon y. And that is why 3 goes down. Now we got this. Now we multiply this. 25 into 16. Okay, we have 3, right? Yeah. 3 2s are 6, 3 5s are 15. Yeah. So this will become 25. 3 2s are 6, 3 5s are 15. So 3 gets cancelled. We get 25 into 16 into 25 gives us 10,000. Right? Yeah, 10,000 it will give. Log of 10,000. Now log of 10,000, how many zeros are there? 1, 2, 3, 4. We can write log of 10 raised to 4. Now this log of 10 raised to 4 is in this fashion. Log of x raised to y. So we can log of x raised to y we can write as y times log x, right? Power comes out. So 4 comes out. 4 into log of 10. Log of 10 to the base 10. When we don't write any base, it means the base is 10. So log of 10 to the base 10 is 1. 4 into 1 is 4. Such a complicated thing, and the answer is so simple, 4. Come to the other one, which is more complicated. 5.96 whole square into 29 whole thing upon square root of 21.56. So we say let x equal to so and so thing. Same thing. Then we take log on both sides. Then this will become log x. The log of this it will become. This we apply log of m into n, and this will log of m upon n for the down one. So we can write this as log of 5.96 whole square plus log of 29 minus log of square root of 21.56. Now log of 5.96 whole square, this 2 power can come out like this, 2 times log of 5. Log of 29 and this square root of 21.56 can be written as log of 21.56 raised to half. Half can come out as like this, half of log of 20. Now you find the log of each one of them. 2 into log of 5. So your characteristic will be 0, and then you find out 59 and 6. Here characteristic will be 1, 46.24 will be the log of that, and here characteristic will be again 1, 33.3. Okay. So now you multiply this thing, you will get 1.5504, 1.4624 remains the same. You divide this and you will get 0.6668. Then you add this first and then subtract this from that addition. You get log of x equal to this. And the further part I have not given, you should know that. Okay, you find the anti-log of 2.3460 and you will get the value of x. Okay, or the value of this particular problem. Okay, so that is how you solve this problem, and this is how logarithm is all about. Finally, we finished with all the chapters. A few things from the past, from our past standards that do not come directly but indirectly can be asked, like square root tables. So do revise if you don't know. These are the squares, these are the square roots. If you remember 8th standard, you would have been doing all this. Okay, you would have been written right up to 20, I think. This is all up to 30. You don't need to really know about 30. Even up to 10 is more than enough. And some revision formulas that again you have done in the 8th standard, 9th standard. A plus b wholes. The most important ones are a plus b whole square, a minus b whole square, and a plus b into a minus b. These three are very, very important, and this not so important, but these three are very important. A plus b whole cube or a minus b whole cube sometimes does come. You can revise on that. A plus b plus c whole square or a minus b minus c whole square or a4 a raised to 4 minus b4 raised to 4. It's very, very rare to come. You can also skip them. Okay, so these are some of the rules, regulations that you need to follow. Okay, so this is it. So with this we end this video. Okay, finally we come to the end of this. This is the entire thing in a nutshell. So I hope I've done justice to the all the chapters of this. So if you watched till here and you already, then you're definitely ahead of a lot of students. Now you need to know, you just need to go and revise once more, see if you can practice more problems from the previous papers, okay, and be ready for maximum marks. Okay, so if you like watching this video, do not forget to hit the like button, share this video with your friends as well as your classmates, subscribe to the channel, and though this is one of your last videos, for those who are watching, who are about to answer in the future, do subscribe to the channel. And this is a QR code. You can always scan this for to follow the WhatsApp channel to see all updates and links to old videos as well as new videos. Okay, there's one more thing that I would like you to do. For all those who are ready, I would like you and who have watched this video, who are ready, who feel that they are done with 40 plus marks, all I would like you to do is just comment 40 plus done. Okay, just comment 40 plus done, and I will know that you are ready for more than half of the paper, ready to get more than 50% of the marks. Okay, so all the very best to those who are appearing for Maths Level 2 examination and for Maths Level 1 examination. I wish you the very best. My best wishes are with you, and do let me know if I can help you in any other way. So thank you, all the best, and I'll see you in the next video, which will be the science video. All the best, you've got this. Take care, goodbye.